Okay, well, let's solve a system here using triangular form. This one does have a solution. The last example I did didn't end up having a solution, but this one's going to have a solution. So let's remember what we want to do. We want to put this in triangular form, and again, go check out page 556 for the definition of what triangular form is. 556. So yeah, check that out. What we're going to do is we're going to write our first equation. We want that equation to have x, y, and possibly z, but it's got to have that x. And we want the coefficient to be 1. The second equation, we want to have x eliminated, and we want to have the coefficient on y to be 1. And then our third equation, we want x and y to both be eliminated, and we want to be left with a coefficient of 1 on z. So if we were to write it here, we would want to, eliminate these terms, and it would look like a, like a triangle, right? Anyway, the moves we can do, let's remember those real quick. We can interchange any two rows or any two equations. We can replace an equation with a multiple of itself. So this one's going to be useful once we've eliminated our desired variable. We can just divide by whatever the existing coefficient is. In this one, we can replace an equation with itself plus a non-zero multiple of another equation. So we're going to use this one to cancel out variables. All right, well, let's get rolling. We want to solve this guy by putting it in triangular form first. Okay, well, our first equation is in good shape, right? We've got x, y, z, and we've got a coefficient of 1 there, so that's good. We don't need to change anything, and that's a sigh of relief. So we can start working on getting rid of the x below it, right? So I can take and start doing these row operations. So if I take row 2 and I subtract off 2 times row 1 and put that in place of row 2, that's going to get rid of the x there. And we can do this maybe at the same time. Let's take row 3 and let's add 3 times row 1, because that's going to get rid of my x, right? I'll put that in place of row 3. So let's do that, and I can write what that is. So we're not changing row 1. Row 1's good, so we want to leave that be. So we got x plus y plus z equals 3. That's great. And then we want to do these things. So in place of row 2, we're going to put row 2 minus 2 times row 1. So I'm going to take this one and take off twice of whatever is up here. So I've got 2x minus 2x, that's 0. I've got minus y minus 2 times y, so that's minus y minus 2y, so that's minus 3y. Z minus 2 times z, so that's minus z. And then I've got 0 minus 2 times 3, so that's minus 6. Okay, now we're going to go for our row 3. So row 3, I'm going to add 3 times row 1, right? If I add 3 times row 1, that's just going to go away. So negative 3x plus 3x, that's 0. So then I've got 5y plus 3y would be 8y. 7z plus 3z. 7z plus 3 times z, that'd be 10z. And then 7 is what I'm pointing to. 7 plus 3 times 3 would be 7 plus 9, so that's 16. That's kind of off the page there just a tiny bit. We can slide that over just a touch. Okay, good. Okay, good. So we are in pretty good shape here, right? I've got that one has y and z, and I can make my coefficient there be a 1 without too terribly much work. So why don't we do that? Let's make that coefficient be a 1. So all we have to do is we can just take row 2 and divide it by negative 3. And I'll put that in place of row 2. Okay, and that's all we're going to do there. Let's not do anything else in that step. So row 1 staying the same. Row 2 now is going to get replaced with negative 1/3 times itself. So we're multiplying row 2 by 1/3 and putting that in there. So I've got row 2 here, and I'm going to multiply everything by 1/3 negative. So -3 times -1/3, that's 1. So I've got y. -1/3 times -1 is +1/3, so I've got +1/3 z. And then -1/3 times -6, that's +2, right? So -1/3 divided by, multiplied by 6, -6. So, -6 divided by -3, right? Same thing, so it's 2. And then we didn't change the other row here. We got 8y plus 10z equals 16. So we didn't change anything about that other row there. Okay, so we're in good shape, right? We've got our first equation here has a coefficient of 1 in front of the x. Next equation here doesn't have an x, the coefficient there is 1, so we're almost there. We just have to eliminate this term so we can see what we're going to do, right? We can take and replace row 3 with -8 times row 2. So I'm going to put row 3 minus 8 times row 2, and I'm going to put that in place of row 3. We're not doing anything with row 1, not doing anything with row 2, so those are staying the same. X plus y plus z equal 3. Y plus 1/3 z equal 2. And then this is the one we're going to replace. So we're going to take row 3 minus 8 times row 2. So row 3 was here, minus 8 times row 2, that'd give you a 0. This one, we would have row 3's position minus 8 times this one. So why don't we can do a little bit of scratch work over here, right? Because what we want to do is 10 minus 8 times 1/3, so that's 8/3, right? So we're just doing a little scratch work there. So 10, we know that that's 30/3 minus 8/3, so that's 22/3. Okay, so our y goes away, right, by design. 8y minus 8y, that's 0. Then I've got 10z minus 8 times 1/3 z would be 22/3 z. And then equal, we've then got 16 minus 8 times 2. So 16 minus 8 times 2. So 8 times 2 is 16. So 16 minus 16 would be 0. All right. So now we just need to get rid of our coefficient there, right? And we can do that by just multiplying by the reciprocal there. That's the word I'm looking for. So I'm going to take row 3. I'm going to multiply it by 3 over 22. I'm going to replace that. So we do. I got x plus y plus z equal 3. I've got this one. It's not changing. And then this one, I multiply everything by 3 over 22. So that fraction just goes away. And 22, or 0 times anything is always 0. So there it is. Okay, so notice we've put this in triangular form, right? This satisfies all of the requirements in that definition on page 556. And notice that, oh boy, it's shaped like a triangle, right? So triangular form. And the convenience of this thing kind of just sort of slaps you in the face, right? So z equals 0. I immediately know that z equals 0. And now if I take that, I can substitute that back up in here. And if I put z equals 0 in there, then I know that y has to be 2, right? Because that term goes away. So maybe I can write this instead of just saying it, right? So let's sub into row 2. And we've got z equals 0. This tells us that we got y plus 1/3 times 0 equal 2. So that tells us that y equals 2. So we got z equals 0, y equal 2, and we can sub into row 1 now. And row 1 was just x plus y plus z equal 3. So I've got x plus y plus z equal 3. So that really quickly, really quickly gets solved, right? So x plus 2 plus 0 equals 3. So subtract the 2 from both sides and we can say x is equal to 1. So we've got x, we got y, we got z, and we can say what our ordered pair solution is. Maybe you can write it in this big space over here. Solution. I said ordered pair. It's not an ordered pair. It's an ordered triple, isn't it? X, y, z. And, you know, we ought to go back and plug that in and verify that it makes it true. And maybe we'll just leave that as an exercise for you to finish. But hey, we found the solution using triangular form.